Good evening to all of you. Voice is not clear? Yeah, okay.
I kept it in unlisted, no? Save. Is it okay now, ma? Voice is not clear. Still, ma, Vedavati? I think it is okay now. Is it? Yeah. Okay, ma. Thank you for responding. These classes are helpful to you or not, ma? Any one of you please respond in the chat box. Why? Because we don't have too much time. That's why first unit is completed. That is covered in the videos. That's why today I will start second unit. Yeah. క్లాస్లో చెప్తే మీరు ఒకసారి చెప్పింది మళ్ళీ మళ్ళీ వినాలన్నా చూడాలి అన్నా దట్ ఈస్ ఇంపాసిబుల్. ఇఫ్ వీ టెల్ లైక్ దిస్ రికార్డెడ్ వీడియో మీకు ఎప్పుడు కావాలంటే అప్పుడు ఎప్పుడు చదువుకోవాలంటే అప్పుడు చదువుకోవచ్చు. సో ఐ థింక్ యూట్యూబ్ ఈస్ ద బెస్ట్ ఆప్షన్. బట్ అవుట్ ఆఫ్ 120 అట్లీస్ట్ 60 కూడా రావట్లేదు. వాట్ హ్యాపెన్ టు రిమైనింగ్ పీపుల్ ఐ డోంట్ నో. అట్లీస్ట్ 50% ఐఎమ్ ఎక్స్పెక్టింగ్ ఫర్ దిస్ క్లాస్ మా. 50% means 60 members. So not even cross 50 count also. So every day 10 minutes అలా వేస్ట్ అవుతూ ఉంది కాబట్టి ఈరోజు 6:50కనే పెట్టాను. మనకి చాలా సిలబస్ కవర్ చేయాల్సి ఉంది ఇవాళ సెకండ్ యూనిట్లో. సో దాదాపు ఒక 30% సిలబస్ కవర్ చేస్తాను ఇవాళ. నౌ ద టైమ్ ఈజ్ 7:10, ఆల్రెడీ 10 minutes ఓవర్. Yeah, 30% cover చేస్తే in the next class. Maybe tomorrow, is it okay, ma? Class at any time, or do you have training tomorrow? మళ్ళీ మిస్కి టైం అవుతుంది. 8:10 కల్లా అన్న వదలాలి కాబట్టి అట్లీస్ట్ 1 hour వీ షుడ్ స్టే. సో ఓన్లీ 17 members. వాట్ షుడ్ ఐ డూ? ట్రైనింగ్ ఉంది. ఓకే, దెన్ నో ప్రాబ్లం. టుమారో ఆల్సో I will put the message in the chat group, ma. If it is possible, I will take. Yeah, okay, ma. Okay. Guys, try to like the video and try to subscribe the channel also. It is useful to you only, okay? And no need to pay any amount, na. చెప్పే క్లాస్ వినడమే కష్టము, మళ్ళీ ఇవన్నీ ఎక్స్ట్రా పనులు కూడా మేము ఎందుకు చేస్తామంటారు కదండి. Yeah, understood, ma. Sai. Okay, ma. So now tell me, the screen is visible to you or not? This screen, ma. I will read out. Yeah. So the title of the unit 2. Is it okay, ma? Guys? Is it okay? The screen. Yeah, it is clear. I think so. Shall I start? Please respond in the chat box. Any one of you, make it fast. Yeah. Thank you very much, Sucharita. So baseband digital transmission, this is the title of the unit 2. So what is baseband digital transmission, bandpass digital transmission, all these topics are covered in the introduction itself. Okay, that's why I'm entering into the syllabus. Okay, one moment please, ma. So up to the previous chapter, we described the various techniques for converting an analog signal into digital form. Now we have the digital signal. So up to the previous unit, we have converted the analog signal into digital signal. Now we have the digital form of signal. So now, how we need to send the digital data? Is there any types of data are present, or directly we can send the received data? So there is another way in which digital data can arise in practice. So coming to practical cases, there are so many options to send the digital data. The data may represent the output of a source of information. Okay, example, a digital computer. When the digital data are transmitted through a band limited channel, when the digital data is transmitting through a band limited channel, then dispersion in the channel, dispersion means noise or so many cases, okay, dispersion in the channel causes an overlap in time between successive symbols. Suppose for example, so here 1 0 1 0 1, when we are sending this digital data as it is, then the dispersion in the channel, noise in the channel can causes an overlap between the samples of symbols like this now. So overlap may present due to the noise in the channel between the successive symbols. So 1 0 there may be overlap, 0 1 there may be overlap because of the dispersion in the channel. This form of distortion, that is overlap of successive symbols, overlap between the successive symbols, is called the distortion. This form of distortion is known as inter-symbol interference. ISI. Again, very important for 2 marks question. What is ISI? Inter-symbol interference. Inter-symbol interference. ISI. Inter-symbol interference. So what is this? Inter-symbol interference means that is actually distortion. So how can we get this distortion? When the digital data is transmitting over a channel, dispersion in the channel causes the overlap between the successive samples. So there may be a chance of overlap between the successive samples or symbols. That distortion is called as inter-symbol interference. Okay. So this is a very serious problem which is uncontrollable by the user. So in this chapter, we present techniques that enable the perfect reception in the absence of noise. Even though we are sending the digital data, that to avoid the channel noise, we need some techniques to send the digital data. The techniques are based on shaping the baseband response of the system. So we have the zeros and ones. How we need to send the zeros and ones? We need some baseband shaping system. Okay, that we will see now. The use of an appropriate waveform for baseband representation of digital data is basic to its transmission from a source to a destination. So we need to choose a shape to transmit the data from source to destination, digital data. So how we represent the digital data? Using the line coding techniques. These are called as line coding techniques. So what are the line coding techniques? How many line coding techniques we have basically? That we will see now. So what is line coding technique? See, line coding. It is a encoding scheme. So what is meant by encoding? Assigning zeros and ones. So it is a encoding scheme. It converts sequence of zeros and ones to a suitable format that can be transmitted over a channel without the noise. So it is a encoding scheme. It converts sequence of zeros and ones to a suitable format for the transmission over a channel. That is called line coding. In line coding, basically two formats are there. Return to zero, non-return to zero. So RZ line coding technique is basically return to zero, RZ, non-return to zero, and RZ. Return to zero, non-return to zero, and RZ. So what is the difference between these two? Return to zero, non-return to zero. Very important for 7 marks question mark. Return to zero, non-return to zero. They will give some data and they will ask for return to zero, non-return to zero format of any technique. Okay. Return to zero. If a pulse reaches to zero before the occurrence of next pulse. Suppose for example, this is 1, this is 1. So this is the pulse. Actually, suppose for example, from here to here a pulse, half, here to here a pulse. So totally one pulse, two pulses are present here totally. Return to zero means if a pulse reaches to zero before the occurrence of the next pulse. So here the occurrence of the next pulse is at this point. If it reaches to zero at the middle. If it reaches to zero, sorry, I'm trying to take the color at this point. If the pulse shape is like this, next the pulse shape is like this. If a pulse reaches to zero before the occurrence of the next pulse, see here at this point the next pulse is occurring, but it reaches to zero before the pulse occurring, that is at the half, then it is called as return to zero format. Understood this guys? I hope so. pulse reaches to 0 before the occurrence of the next pulse, then it is called return to 0. Next, non-return to 0, if a pulse does not reaches to 0 before the occurrence of the next pulse, that is this one, 1, 0, 1, 0, so 1, 0, 1, 0. So there is no reaching to 0 before the next pulse occurrence. This type of format is called as non-return to 0. I think it is clear, ma? If the pulse is like this, then it is called as return to 0. Green color indicates return to 0, orange color indicates non-return to 0. So we will get the half pulse in return to 0. So now here I am going to show one example. 1001, this is my digital data. Return to 0 means actually we need to get the full pulse here, but only half pulse is present. That's why it is called as return to 0. Half pulse, half pulse. For 0, 0 is there. In some cases we will get only half pulse for 0 also. Okay. And non-return to 0, 1, 1, 0, 1. Okay. Actually here it is. So 1 here and 0. So this is the actual shape. Okay. So you get the signal for only half of the duration. Return to 0, non-return to 0, I think it is clear. Pulse is present half of the symbol duration, that is return to 0. If the pulse is present for entire symbol duration, then it is called non-return to 0. Next, how many types of line coding techniques or discrete PAM codes we have, that we are going to see now. This totally 6 types ma. Unipolar, polar, bipolar, split Manchester format, polar quaternary non-return to 0 format, differential encoding. These are the 6 types of the line coding techniques. So basically we are going to return to 0, non-return to 0. So what are the main types? Unipolar, polar, bipolar, split, polar, quaternary, differential encoding. And in this unipolar, polar, bipolar are having return to 0, non-return to 0. Coming to 4, 5, 6, we don't have return to 0, non-return to 0. Only return to 0 type we have. Okay. So what is unipolar? What is polar? What is bipolar? That we will see now. Unipolar, the name itself indicates single polarity or one polarity. Bipolar means two polarities. Polar means positive, negative. We can say like that. So bipolar, two polars, unipolar, single polar. Polar means positive, negative. Like that we can say. How the waveforms? See here. In the unipolar format, this is also known as on-off signaling scheme. If you see on-off signaling scheme, so 1 means we will get the pulse, 0 means no pulse. That is unipolar. Single polar. For symbol 1, we will get the pulse. For symbol 0, there is no pulse. That is 0. That is called as unipolar format. Symbol 1 is represented by transmitting a pulse, whereas symbol 0 is represented by switching off the pulse. When the pulse occupies the full duration of a symbol, the unipolar format is said to be non-return to 0 type. When it occupies a fraction of the symbol duration, it is said to be the return to 0. Here, this is fraction. Actually, we will consider it as half of the symbol duration. Okay. Theoretically, to draw, we will say half of the symbol duration is non-return to 0. See here, unipolar. Coming to, if we consider unipolar, for 1 symbol should be there, for 0 no symbol. So 0 no symbol, 0 no symbol, 0 no symbol, no symbol. And here 1 means half of the symbol duration. 1 means we need to get the pulse, full pulse, but we'll get only half pulse. Why? Because non-return to 0. Here also same. Okay. Sorry, return to 0. Coming to non-return to 0, 0 means 0, 1 means full duration, 0, full duration. This is about the unipolar. Coming to polar. So here positive and negative we need to get both. Polar means. Okay. For 0 we will consider it as negative. For 1 we will consider it as positive. So 0, 1, 1, 0, 1, 0, 0, 0. By seeing this we can say that what is the digital data. Okay. So let's do this. Then it is easy. You can get the data also. Yeah. See, 1 half of the symbol duration, 1 half of the symbol. If you observe return to 0 unipolar, polar return to 0. See here we have the 0 and pulse is negative half. And here there is no pulse. Why? Because unipolar means on off. For 1 we will get the pulse, for 0 no pulse. That's why here also return to 0 no pulse. Coming to here polar return to 0, 0. Actually it should be like this, but it is written to 0, that's why only half we will get. 1 half, this one half, again 0, only half, again half, for 0 half, half, half. So this is about the polar return to 0. Coming to polar non-return to 0, this one. So for 0 we have negative amplitude, for 1 we will have positive amplitude. So polar means positive and negative. Positive and negative. Unipolar means for 1 we will get the pulse and for 0 no pulse. That is the difference between these two, unipolar and polar. I think it is clear to you. So here write up for the polar format. In the polar format, a positive pulse is transmitted for symbol 1 and a negative pulse transmitted for symbol 0. It can be of the non-return to 0 or return to 0 type as shown in above figure. Unlike the unipolar waveform, a polar waveform has no DC component. There we have DC component. And here that the zeros and ones in the input data occur in equal proportion. Okay. Next, coming to the third one, bipolar. In the bipolar format, also known as pseudo ternary signaling. Can anyone say what is meant by pseudo? Everyone knows about sudoku, pseudo. What is pseudo? Can anyone of you please respond in the chat box? What is the general meaning of pseudo? Pseudo? Don't know. Duplicate ma. Pseudo means duplicate. Also known as pseudo ternary. Duplicate ternary signaling. Ternary. Why the name is given as ternary? Ternary means generally 3. You know very well. Quat means 4. Duo means 2. Ternary means 3. So why this is called as pseudo ternary signaling? And positive and negative pulses are used alternately for the transmission of ones. So both positive and negative pulses are used and 0 also used. So 0 positive amplitude level, negative amplitude level. 3 levels are present in this bipolar format. That's why the name is given as ternary. Pseudo ternary. Why the pseudo means? We don't know first one is related to positive or negative and the next one is related to positive or negative amplitude level. Based on the first assumption, we will consider it whether it is related to positive or negative alternately. That's why the name is given as pseudo ternary. With the alternation taking place at every occurrence of a 1, the pulse will change its amplitude level from positive to negative, negative to positive. And no pulse for the transmission of zeros. It can be of the return to 0 or non-return to 0 type. In this representation, there are three levels, +1, 0 and -1. Hence the name pseudo ternary. Okay. See, bipolar return to 0 and this one is bipolar non-return to 0. See, observe the difference. I have taken the data 0, 11, 0, 1, 0. First, if the first one I am assuming as positive amplitude and the next one pulse should be negative amplitude. Next, for 0, it should be 0, and for 1, here previous one is negative amplitude level and the next one should be positive amplitude level. For the alternate ones, the amplitude levels are changing from positive to negative, negative to positive, alternatingly. Okay, see here 1, next 1, that's why negative amplitude, 0, 0 amplitude level, again 1, positive amplitude level. So here it is negative, for the next one it should be positive. This is about the bipolar. Bipolar also called as alternate mark inversion, AMI. Draw the AMI waveform for the given data. Alternate mark inversion, it is also called as bipolar. Okay, so remember this point, very important again for competitive exams as well as for external exams. Bipolar, pseudo ternary, alternate mark inversion, three are same. So three names for bipolar, pseudo ternary, alternate mark inversion. Okay, I think up to bipolar it is very clear. I think so. If you have any doubt, please respond in the chat box, guys. Are you there or not? I don't know. Are you there, ma? Any one of you, please respond in the chat box. Yes, okay. Yeah. Next one is the split Manchester format, also called as biphase baseband signaling scheme. Split Manchester format, also called as biphase baseband signaling. Symbol 1 is represented by transmitting a positive pulse for one half of the symbol duration, followed by a negative pulse for the remaining half of the symbol duration. Likewise, for symbol 0, these two pulses are transmitted in reverse order. So, split phase Manchester format. Suppose for example, I think I forgot to draw this one, Manchester format. Yeah, diagram is not there. Okay, and no problem. I will draw here. For this split phase Manchester format, I am going to draw. What is the data here? 0, 1, 1, 0, 1, 0. Color is not visible. I will take red. Yeah. So split Manchester format. So what they have given? One representing a positive pulse for one half of the symbol duration, followed by a negative pulse for the remaining half duration. That is called as Manchester format or biphase signaling format. Manchester format or biphase signaling format. So that is not in the textbook also, ma. Okay, Simon Hacking textbook, not there. So please, and reverse order for the 0. First, according to the statement, I will draw for 1. First half negative. 1 again. Again 1. That's why positive. This one. Again here 1. So positive amplitude. Negative. So 1 is represented by transmitting a positive pulse for one half of the symbol duration. This is the total symbol duration. Half of the pulse is positive, followed by a negative. Half of the pulse is, half of the pulse is positive, followed by a negative pulse. Half of the pulse is positive followed by a negative pulse. For 1, 1, 1. For 0, reverse. So 0 means actually it is negative pulse 0. Negative pulse 0. Negative pulse 0. So biphase signaling scheme are also called as split Manchester format. For symbol 0, these two pulses are transmitted in reverse order. So first one is positive, negative, and for 0, first one is positive, negative. Is this right or wrong? You have to tell me now. According to our statement, is this right or wrong? So now, is this Manchester format? Then why the name is given as split? If you observe this one, it is similar to another format. Is it right or wrong? If you draw like this. So, what is the actual drawing of split Manchester format is? Listen carefully now. So, this is related to another format. According to statement I have drawn, but there is a split is there. So what does it mean? మనం ఏదైనా ఒకటి కావాలంటే ఫస్ట్ అంతే కదా, మీ స్టేట్మెంట్ వినగానే డ్రా చేసేది అదేగా, పాజిటివ్ పల్స్ అండ్ 1/2 ద సింబల్ డ్యూరేషన్ ఫాలోడ్ బై నెగిటివ్ పల్స్. సో నేను 0 డ్రా చేసినప్పుడు కూడా ఎవరేమనట్లా, నెగిటివ్ పల్స్. సో పాజిటివ్, నెగిటివ్, positive, negative. This is also one na. Positive, negative. This is for symbol 1. Is it right? For symbol 0, just reverse. So first it will start by negative pulse, ended at positive pulse. Negative pulse, ended at positive pulse. Negative pulse, ended at positive. This is called as Manchester format. Manchester format. Now the statement is, see now, symbol 1 represented by a positive pulse for 1/2 of the symbol duration. 1/2 of the symbol duration followed by a negative, not 0. So it should be negative. That's why negative half. Ended at negative half. Okay. So this is the Manchester format. I think it is clear to you. I forgot to draw while drawing the text. That's why I have drawn like this. Okay. Next one is polar quaternary. The utilization of bandwidth can be made more efficient by adapting an M array for the representation of the input binary data. So up to now we have seen so many formats: unipolar, polar, bipolar, Manchester format. So now we are approaching to another technique, that is the polar quaternary. So what is polar quaternary? From where we have got this technique, that we will see now. The utilization of bandwidth can be made more efficient by adapting an M array format. So this is the M array format ma. M array format. ARY. M array format. So to use the bandwidth of the signal efficiently, we need to get the one more efficient technique, that is M array format, for the representation of the input binary data. Utilize the bandwidth. An example of this representation, M array format example is polar quaternary. So to use the bandwidth of the signal effectively, we use the M array format. The example of M array format is the polar quaternary format of the non-return to zero. So up to 3 cases we have return to zero, non-return to zero. Fourth case is split phase Manchester format or biphase signaling scheme also called as. Okay, positive and negative we got. That's why there also we don't have return to zero and non-return to zero ma. Okay, in that Manchester format. Now in this polar quaternary also we don't have return to zero and non-return to zero. We have only non-return to zero one type. But this format, non-return to zero format, is divided into two formats: natural encoded, gray encoded. So what is the difference between natural encoded and gray encoded? See here, we assumed some levels ma. You can assume, but 0 0 should be least amplitude level, 1 1 should be highest amplitude level. Compared to 0 0, 0 1 should be more. Compared to 0 1, 1 0 should be more. Likewise, you need to assume the levels, amplitude levels, to draw natural code and gray codes. Coming to natural code, for -3, I have considered the levels as -3, -1, +1, +2. You can consider -2, -1, +1, +2 also, no problem. Or 0, 1, 2, 3, 4, that is also no problem. Only positives, that is also no problem. According to your wish. Okay. So -3, 0, 0, -1, 0, 1, +1, 1, 0, +3, 1, 1. So these are in the order. Minimum value, maximum value, in between values. Okay. You can consider 0, 1, 2, 3 also, no problem. Okay guys? Yeah. Next, coming to gray code. So how can we write this gray code? So have you heard about this word gray code anywhere? Have you heard about this? Wrong ma'am. What is wrong ma? Sucharita? False. Yes ma'am. So you are responding to my... Okay, no problem. Yeah, okay ma, no problem. So see here, have you heard about this word gray code anywhere? Gray code. In STLD అంటే మీకు టైటిల్ ఏంటో DDTVనా DCD something it is. In Manchester format. Okay ma. No problem. Wrong ma'am annara. Manchester format. Yes ma. Okay ma. You are responding. At least 10% responding. Okay, no problem. Now tell me, how can we write the code for the gray format? See here, 0 0, 0 1, 1 1, 1 0. This is the natural code and this is the gray code. Why I have written like this? Because see here, whenever we are moving from 0 0 to 0 1, only one bit has to be changed. From 0 1 to 1 1, again only one bit change. This is same. Next, coming to 11 to 10, again only 1 bit change here. And here 1 bit change. Whenever we are moving from first to second, this is used in K-map, Karnaugh map. You will use this coding 0, 1, 2, 3. Whenever we are moving from row to row, column to column, there should be only one variable change. So same principle here also to write the gray code. That's why we have written like this 0, 0, 0, 1, 1, 1, 1, 0. Now if we compare this one with this amplitude level, 0, 0 is indicated with -3, 0, 1 is indicated with -1, 1, 1 is indicated with +1, 1, 0 is indicated with +2. So after writing this table, we need to divide the digital data into die bits. So we need to divide the digital data into die bits. That means die means 2 bits. So whatever the digital data given to you, to draw polar quaternary, that may be natural code or gray code, first of all you have to draw the table according to the amplitude level, then divide the data into 2 bits, die bits. So divide the data into 2 bits to draw the waveform. So now this is my data 0, 1, 1, 0, 1, 0, 0, 1, 1. Now I have divided this data into 2 bits 0, 1, 1, 0, 1, 0, 0, 0, 1, 1. Coming to natural encoded, 0, 0 is indicated with what? 0, 0 indicated with, sorry, here we have first 0, 1. 0, 1 means this one. So this one is indicated with what? -1. Next coming to this one is this amplitude level. Okay. Next 1, 0. What is the level for 1, 0? +1. Again 1, 0, +1. Next 0, 0. What is the amplitude level? -3. -3. Okay. Next, for 1, 1, what is the amplitude level? +3. So this is the diagram for natural encoded. Coming to gray encoded, for 0, 1, what is the amplitude level? -1. That's why -1. Next, for 1, 0, +1 for natural code and +3 for gray encoded. So 3 here. Next also 1, 0, 3 here. Next to 0, 0, -3 for gray encoded. -3. Next for 1, 1, +1. That's why here it is +1. So likewise, first of all, write the natural code and gray code and represent the levels. Then divide the data into 2 bits. Okay. So this is about the polar quaternary format ma. So this is the write up for the explanation. A polar quaternary code has 4 distinct symbols referred to as die bit. That means pair of bits. Each die bit is assigned a level in accordance with the natural code described in above table. To obtain the waveform, the input binary sequence is viewed as a new sequence of die bits, and each die bit in the sequence is represented by a level of its own. So according to your wish, you can consider the level of amplitudes. A secondary coding scheme called the gray code, in which the adjacent bits are arranged in such a way that they differ by only 1 bit. Okay. Explanation I have written like that's it. Last one is the differential encoding. Last one is the differential encoding. Differential encoding start with an arbitrary initial bit. So the initial bit you can take it as positive level or negative level. Here this is also our wish mark. Initial bit is positive or negative, to draw the differential encoding. In our example, I am considering the initial bit level as positive. Okay, in our example, I am see here initial bit level may be positive or negative. In our example, I am considering the initial bit as positive. Remember this point. The information in the input binary sequence itself is encoded in terms of signal transitions. Whenever the signal level is changing from 0 to 1, 1 to 0, there is a transition in the levels. For example, a signal transition is used to designate zeros and ones. See here, for example, I am considering a signal transition is used to designate the symbol 0. So, whenever symbol 0 is present, why signal transition is present, and there is no transition is used to designate symbol 1. In the given data, if 1 is there is no transition, when 0 is there is a transition from positive to negative and negative to positive. For example, see here, this is the initial bit. I have considered it as positive amplitude level. You can consider it as negative amplitude level also, no problem. Okay, initially. So 0 I am considering as transition occurs. So here positive is there previously, 0 occurs, hence it has to change its level from positive to negative. Why? Because here I am considering transition occur. Example I am considering. You can consider transition occur for 1 also, no problem. And there is no transition for 0 also, that is also no problem. Okay. Differentially encoded. So there is a difference between for 1 and 0. Okay. See, 0 transition occur, 1 no transition, amplitude level, negative amplitude level as it is. Here also 1 no transition. Here 0 we get, that's why transition from negative to positive. 1 no transition. 0 means transition from positive to negative. Again 0 transition from negative to positive. Again 0 transition from positive to negative. 1 no transition, 1 no transition. So likewise we can draw the differential encoding format. So first of all we need to take the initial bit level. According to the initial bit level, you can take transition for either 0 or 1, your wish. So let us consider only one transition, not for the both symbols. Okay. So differentially encoded format. So these are the 6 formats of the digital data representation. In the first unit, we have covered the converting the analog into digital signal. Now we have the digital signal. How many formats are there to send the digital signal? Unipolar, polar, bipolar, Manchester format, polar, quaternary, differential encoding. These are the 6 types of the digital data representation format. Okay. And next, this is the important table ma. Please take the table guys. For the next class, from this table only, next half of the unit will be covered. From this table only. Take this table. Please all of you note down the table at least. I will read out after writing. Next one is power spectra density of format. So to calculate the power spectral density or to get the power spectral density expression for unipolar, polar, bipolar, Manchester polar quaternary, this table is very important ma. So here unipolar, what is the amplitude level for this unipolar? For symbol 1, A, that is positive. Symbol 0, there is no pulse, 0. Polar, for symbol 1 A, for symbol 0 minus A. Bipolar, AK, that is amplitude level. A and minus A alternate ones, 0 for symbol 0. For Manchester, AK is equals to A for symbol 1 and minus A for symbol 0. And here the pulse is doublet pulse. For 1 we will have plus or minus 1. For 0 also we have plus or minus 1. Okay. Polar quaternary, AK is equals to, according to your amplitude, if you have considered 0, 1, 2, 3, you can consider like that also. Here I have considered like this now. For 0, 0 minus 3A, 0, 1 minus A, 1, 0A, 1, 1, 3A, dibits. AK is equals to. If you observe the basic pulse shape, V of T of different formats. For unipolar, polar, bipolar, the pulse shape is same. That is V of T consists of rectangular pulse of unit amplitude and the duration is TB itself. Coming to Manchester format, the duration is TB, bit duration, but the pulse is doublet pulse of height plus or minus for both symbol 1 and symbol 0, doublet pulse. And coming to polar quaternary, consists of rectangular pulse of unit amplitude and the duration here is 2 TB. Why? Because up to these 4, the shape is considered up to TB, single pulse. But here we are considering 2 bits, dibits. That's why the pulse duration is 2 TB. That is the difference. So without this table, అండ్ ఈ టేబుల్ మీకు ఇవి ఎలా రాసామో కూడా అర్థం కాకపోతే కనుక నెక్స్ట్ పవర్ స్పెక్ట్రల్ డెన్సిటీ అనేది క్యాలిక్యులేట్ చేయడం మీకు టఫ్ అయిపోతుందమ్మా. ఓకే, సో ప్లీజ్ టేక్ ద టేబుల్. Yeah, shall I close this session, ma? దీంట్లో కూడా లాక్ చేసేది ఉంటే బాగుంటుంది, పర్సన్స్ వచ్చాక మళ్ళీ బయటికి వెళ్ళకుండా. For gray encoded, okay, you are asking for power spectral density, ma? Is it right? How many I have given here? So we calculate up to Manchester format itself, ma. polar quaternary also. Just I will give the, so for natural coding only we will do grade coding. Actually polar quaternary for spectral density also is not in our syllabus. Okay, so but I will give the instructions how to do. According to that you can take it for grade coding also. See here, just these will change, amplitude levels will change, that's it. Entire thing is same. Okay, so if you want you can do on your own. So that's it about for today class. In the next class, don't skip the next class no power spectral density. సో ఒక్క పవర్ స్పెక్ట్రల్ డెన్సిటీ క్యాలిక్యులేట్ చేయడం తెలిస్తే ఒక్క టెక్నిక్కి రిమైనింగ్ టెక్నిక్స్ అన్ని చాలా ఈజీగా అర్థమవుతాయేమో. లేదు అంటే ఇంకా రాకపోతే నేనేం చేయలేను, లేదంటే నెక్స్ట్ వీడియో చూసి అయినా తర్వాత రావడానికి ట్రై చేయండి క్లాస్కి. ఓకే, సో మెనీ పీపుల్ ఆర్ absent. I don't know why, because shall I wind up for today? Yeah, okay ma, thank you so much Sucharita. Only Sucharita and only Sucharita is there, I think so. It is also there. Vaishnavi is there. Only 9 members are there, ma, that's why I'm asking. Yeah, Obaya is also there. Okay guys, no problem. తర్వాత అయినా వీడియోస్ వాచ్ చేయండి అమ్మా, మీకు ఎగ్జామ్స్కి కూడా బాగా హెల్ప్ అవుతుంది. ఏమైనా డౌట్స్ ఉంటే నన్ను పర్సనల్గా అయినా అప్రోచ్ అవ్వండి, వాట్సాప్ అయినా చేయండి, కమెంట్ అయినా చేయండి. ఈ రిక్వైర్మెంట్ని బట్టి. యా, షల్ ఐ క్లోజ్ ద సెషన్ మా? ఓకే అఖిల్, థ్యాంక్ యూ మా, థ్యాంక్ యూ ఫర్ అటెండింగ్, థ్యాంక్ యూ ఫర్ రిక్వెషన్స్. మా శ్రీనాథ్ మీరు కూడా ఉన్నారా? ఏంటమ్మా శ్రీనాథ్ ఎవరు అటెండ్ అవ్వట్లేదు? మళ్ళీ వాచ్ చేస్తున్నారా అట్లీస్ట్, లేకపోతే ఎగ్జామ్స్ అప్పుడు చూసుకుందాం అనుకుంటున్నారా? వాట్ ఇస్ యువర్ ప్రాబ్లం? ఇది మీకు అవైలబిలిటీ టైం అనే కదండి చెప్పారు, 7:15 నుంచి 8 వరకు. 8 to 8:30 కావాలంటే నెక్స్ట్ వెళ్తాం అనేసి హాస్టల్స్ కూడా చెప్పారు. మీ అవైలబిలిటీని బట్టే నేను ఈ టైంలో తీసుకుంటున్నాను. అయినా కూడా చాలా మంది రావట్లేదు. వాట్ ఇస్ ద రీజన్? తర్వాత అయినా వాచ్ చేస్తున్నారా? అట్లీస్ట్ క్లారిఫికేషన్ ఇవ్వండి నాకు. నెక్స్ట్ ఇంకొకటి ప్లాన్ ఏంటంటే, నేను బీసీ హార్డ్వేర్ కిట్స్ కూడా ఎక్స్పెరిమెంట్స్ చేసి పెట్టాలి అని అనుకుంటున్నాను. సో ఇఫ్ పాసిబుల్ ఆన్ సాటర్డే ఐ విల్ డూ ఫర్ అట్లీస్ట్ 2 experiments. ద థింగ్ ఈజ్, నేనే వీడియో తీసుకుంటూ నేనే ఎక్స్ప్లెయిన్ చేయాలి అంటే నాకు కొంచెం టఫ్గా అనిపిస్తుంది. కాబట్టి ఎవరైనా ఎక్స్ప్లెయిన్ చేసే వాళ్ళు ఉంటే వాళ్ళని పట్టుకొని వాళ్ళకి నేను వీడియో షూట్ చేయాలి. యా, శ్రీనాథ్ ఆర్ యు దేర్ మా? ప్లీజ్ రెస్పాండ్ ఇన్ ద చాట్ బాక్స్. మీ అవైలబిలిటీ టైం అనే నేను చెప్పాను. ఓకే, రావట్లేదు, తర్వాత అయినా వీడియో వాచ్ చేస్తున్నారా లేదా? అండ్ పీడిఎఫ్ ఆఫ్ దిస్ ఐ విల్ పుట్ ఇట్ ఇన్ ద డిస్క్రిప్షన్ మా. ఓకే, ఎస్టర్డే ఆల్సో పెట్టాను నేను డిస్క్రిప్షన్లో పీడిఎఫ్, అది డౌన్లోడ్ చేసుకోండి, కావాలంటే చదువుకోండి. శ్రీనాథ్ ఆర్ యు దేర్? వెళ్ళినట్టున్నారు, చిన్నప్పుడు వెళ్ళిపోయినట్టున్నారు. క్వశ్చన్ యా, వాట్ ఈస్ ద ప్రాబ్లం? డే స్కాలర్స్ ఓకే, హాస్టలర్స్ ఏంటి? హాస్టలర్స్ అయినా రావచ్చు కదా, వాళ్ళకేం పని చేసేది ఏమి ఉండదు కదా. తర్వాత వీడియోస్ వాచ్ చేస్తున్నారు, అట్లీస్ట్ ఆ క్లారిఫికేషన్ అని ఇవ్వండి నాకు. ఓకే సీనా, టాక్ టు యూ లేటర్. చెప్పట్లేదు నాకు ఆన్సర్. యా వాచింగ్ మ్యామ్. ఓకే సీనా, దట్స్ ఫైన్, దట్స్ ఫైన్ మా సుచరిత, థ్యాంక్ యూ మా. తర్వాత అయినా చూడండి. అండ్ మీరు ఎగ్జామ్స్ అప్పుడు కావాలంటే కూడా మీరు మళ్ళీ వీడియోస్ చూసుకోవచ్చు, మీకు అవైలబిలిటీ ఉంటాయి కాబట్టి. ఓకే, థ్యాంక్ యూ సో మచ్ సుచరిత, శ్రీనాథ్, వైష్ణవి, ఓబయ్య, థ్యాంక్ యూ వెరీ మచ్ ఫర్ అటెండింగ్. I'm going to end this session, ma. Bye to all.